Okay, we start with the presentation of today, and we will speak about the Team Diana, our team, and what consists about, what we do, and everything probably you need to know about Team Diana and what we do. At the end of the live, we will, before the end, we will listen all your questions on the chat. Anything you will write there, and we will answer all your questions. We are Team Diana, and yes, this is what the agenda for today. We will introduce you Team Diana, what is it, what we do. Then my colleagues will introduce you to the activities. There are several aspects that we need to cover because probably you are interested on some aspect of engineering. And then we will introduce what we are searching in the recruitment. And then we will explain what are the possibilities inside of a team. Okay, who we are? We are a student team, and we like to build some robotic systems, and these systems are rovers, basically. Probably if you are in this live, probably you already know what is a rover, and we are actually like a group of friends that meet together and put some knowledge together to take forward this kind of activity. We are plenty. We range between 40 up to 60 members in a year. And there is a huge number of contributors inside of this team. The team started in 2008 with a project. It was called Amalia. It was the first rover of Team Diana, and it was built with the purpose to participate to a competition, the Google X Lunar Prize. It was a rover for moon applications, and the winner of this competition actually will maybe it wasn't so, but there was a possibility that the rover could go on the moon. There was participation of 2 other universities. The purpose of Polytechnico was to build a rover, and this was the prototype, the first prototype of Amalia. Then we built the second one. It was Amalia 2, version 2. It was upgraded version of the first one, and for the same purpose, on the lunar environment, and was built for the purpose of space. Then we moved to another kind of rover, the Toro rover. It was built not for our satellite, but for Mars planet, and we changed competition, and we built another kind of structure. It was bigger because the environment of Mars required different characteristics, and was also equipped with an arm. We moved then along the years to another kind of rover. It was Trinity, another prototype, and as you can see, it is an upgraded version of the previous one. We try to evolve every project we do. The rover, you see, is increased in size, and is equipped with other kind of wheels. We use harmonic steel for wheels, and we conducted some other studies to build this rover. Now we are developing a new kind of rover. It is Ardito. It is a very brave project. We try to put all efforts in this project, and it is a very big upgrade to the previous versions. It is equipped with arm, a deep sampler, a scientific laboratory on board. All the logic is on a very upgrade to the previous one. We have instruments on board, like a stereo camera to reconstruct the environment, and we have really upgraded this rover. It's currently work in progress, and this is where probably, if you're interested in entering the team, this is where probably you will work. All the previous rovers are integrated in this kind of in Ardito rover. This put together all the knowledge we gathered during the years. Our mission is to stay on Earth for the moment, but we look forward for the extraplanetary environment. And our mission actually is to prototype, do research with the knowledge we get during lessons, and we like to go out to the lesson with the knowledge we have gathered during the lesson, and test what we learned during the courses, and to build a robot, basically. We don't go to Mars for the moment. We don't know actually if in the future we'll change this, but we participate to some challenges, and for each challenge we create a mission for the purpose of a challenge. We have we created 4 missions for the moment to participate to some competitions. There are several competitions in the world, but we focus to two of them. There is one in Europe, and is the European Rover Challenge, and one in USA, that is the University Rover Challenge. These 2 competitions are managed by some companies or societies. For example, Mars Society, if you already know what is it, it's the society that has created this kind of competitions. There are also some contributors from other companies, also from aerospace industry, and these competitions give us some requirements what a rover should do, because we don't go to Mars, but staying on Earth we can prototype a robot for simulating the environment, the mission, the tasks we need to perform, and everything we need to take forward with the rover. There is some rivalities with other universities. There are plenty of universities, usually is from 30 up to 60 university participating, other teams participating to these competitions, and we need to perform better than the other. It's like a sport, but with engineering. The European Rover Challenge is take place in Poland, and they reconstruct, the staff reconstruct all the what Mars should look like, and it's a very hard terrain to travel across, and the rover should perform some tasks on this terrain. We need to collect science samples, or perform some actions on a panel, for example for maintenance purposes, or collect other kind of objects of interest on the terrain. The other one is the University Rover Challenge. If the first European Rover Challenge is focused on multi-purpose aspects of the rover, the University Rover Challenge is an endurance one. And you see on the presentation there is a huge desert. It's actually, the competition field is up to 1 kilometer big. It's very huge, and this could also put some difficulties on telecommunication, power system, and other kind of aspect from the computer on board that needs to remember where the rover has passed, and increase the difficulty on endurance aspect. For the project, all the project we do are very complex. We need different kind of devices, structures, programs. There is a big variety of what we need to do, from PCBs, softwares, the telecommunication, algorithm research, or just for, like, for example, computer vision, material research. We need also to perform some biological analysis, and we need to create devices that will for the scientific laboratory on board. And all these aspects from all kind of engineering and not are put together to build this kind of complex system. For this purpose, we have different sections in the team. For example, we have a mechanic group, electronics, computer science, science, media design, and a section for management. You see they are all very different aspects from one another, and you can also see media design. You probably could think that it's not something that a robotic system should have, but actually it's very important because the competition also requires to take care of these aspects. For example, the image that the rover should have, or video making and other kind of activities. My colleagues after me will talk about in details what this subgroup will actually do inside this by designing all these aspects. And for the moment, I will glad to leave the place to my colleagues after me. We will change. Probably you will see this during the presentation. We need to put the face mask on us to wear it because we are in a particular situation. So the moments probably will take some minutes for the changes. Bye. We see you later from the question and answer later on.
Hi everyone, I'm Leonardo Festa, lead of mechanical department. Our department is mainly composed by students from mechanical and aerospace engineering from both bachelor and master courses. We develop, build and validate all the mechanical components of our rovers, from the mobility system to all the electronic component supports. The design process of each mechanical part follow a cyclical path that is very important to us. It starts with a big brainstorming needed to understand what are the mechanical requirements to participate in competitions. Once we have enough ideas, we start drawing CADs. Then we pass to structural and or dynamic analysis in order to understand the feasibility and reliability of each component. If we are satisfied with the results, we can finally produce the parts and assemble them. Otherwise, we go back to the CADs and design stage. In this slide, you can see the difference between the last year project Trinity and the nowadays project Ardito, in which you can see that we enhance the rover by enlarging the wheels and put them on a straight line in order to achieve a better grip and stability on the terrain. So the process continues every year, because once the rover is tested, we discover every year some adjustment to be made, and so the process continues every year, and it's an ether that is necessary to build a mechanical and efficient system. So I now pass to my colleague that will present some softwares that we use.
Okay. Hi everyone, my name is Stanislao Trofa, and I'm an old member of Team Indiana. Actually, this is my fourth year in this team. I work in the mechanical division, and today I'm here to introduce you some of the fundamental instruments that we use in the design process. These instruments are both the software we use to define the geometry and for the validation of every component, and the production technology that we can use. For what concerns the software, we use SolidWorks for CAD modeling, and here you can see some model that we created in the last years. For what concerns the FEM analysis, we use software like Pattern and Naturam. This software are used for FEM analysis. In particular, Pattern is the pre and post processor, and Naturam is the solver. We use them for structural analysis, both linear and non-linear, such as static analysis, dynamic analysis, pre and post buckling analysis, and also for topological optimization analysis. We also use for the topological optimization analysis ANSYS, and for the classical structural analysis Apex. Other software that we use are ADAMS, that is a multi-body dynamic software that we use to study the dynamics of moving parts and how loads and forces are distributed on a mechanical system. We also use ADAM and ModFrontier. ADAM is a discrete element modeling software used for simulate and analyze the behavior of bulk material, and ModFrontier is used also for the optimization analysis. This year, for what concerns the software, we are also interested in learn CFD software, because we want to make some thermal analysis to optimize the cooling system for the electronic parts that are inside the chassis. Another important aspect is the production technologies, and as you know, in the design process of every component must be into account must take into account the manufacturing process that we will use to product that component. So it is very important to define that process. One of the aspects that characterize our team is the possibility to use not only the traditional production technologies, but also the additive manufacturing technologies. This is an important aspect because it gives us many possibilities, and in particular the university allow us to use different kind of 3D printers, and also this year we have the possibility to print using metal powder. So it is a very it gave us a great advantages because we can design components that are smaller and more resistant. Okay, I'm done.
And so, what we are looking for this year is mechanical and aerospace, but also other kind of other courses interested in learning mechanics and learning software to develop mechanical system, and we will validate your candidature when you will be applied for the form. And now I give the screen to the electronic head, Eduardo Acchetto.
Hi everybody, I'm Eduardo Vacchetto, and I'm the lead of electronic department. Our electronic subgroup is composed of students coming from bachelor and master degree, but we are open to everyone. As we are electronics, we take care of hardware development as analog and digital circuit, the development of a PCB, but also we develop the firmware useful for the board that we developed. You can see a very funny image in this slide that explain how to don't use a solder iron. Okay, so in this slide you can see two schematic, very synthetic schematic that represent the power connection and the signal connection that we have on the rover. This schematic represent well all this work, like analog and digital development, firmware development, but also the most important things, I think, like the cable management and internal wire communication. Last year we made some change in the structure of the electronics, and we started to use another principal wired communication to let the principal board to communicate each other. We used an Ethernet bus that is more powerful than the CAN bus, because we can transmit and receive a lot of data and let us to reduce the number of cable. So due to these changes, The work for this year will mainly focused on the hardware development of the board, like the wrist board, a board that with sensor and control the actuator on the wrist. We have to design a board that control the power system and deliver the power to every board, and with the consumption of this. In case of a malfunction, it can detach it to the whole network, power network of the rover. Okay. So now we can see specifically this task, these three main tasks. So we have the hardware development. We take care of the whole production process of the hardware development. So, for example, from the left you can see a schematic. In particular, this is a CAN transceiver. And this is the first thing to do, to develop an electronic circuit. But this is not the first thing we do. Because the first thing is to represent the circuit on a sheet with a pen, and then broke it to a EDA software to simulate it and to test the capabilities. Then, since the simulation normally deviates slightly from the real behavior, we build some prototype to test the characteristics of the circuit that we developed. Then it's time to produce the printed circuit board, if the circuit is working, naturally. So you can see a capture of a PCB design on the left. This design was made with KiCad, the mainly software that we use for this purpose. It's a very powerful software. It has a lot of tools useful to develop and test the board, and also to simulate some characteristics. Then we have to solder the board we developed. We did it in our laboratory with by hand or with a reflow oven. Okay, so in this slide there is a little list of software tools and laboratory instruments that we use for design, production and testing. I think that soon we can return to the laboratory in the Politecnico. Okay, the second task that we deal with is the firmware development in a tight contact with the computer scientist. The mainly used language is the C language for the microcontroller programming, but we also use some initialization software to make a fast development of the project. We use a lot of IDE. Everyone can use his favorite IDE. I wrote some examples like Visual Studio Code, System Workbench, etc. Okay, here we have some example of a typical firmware that we need this year. For example, we have to read and manage the data coming from a sensor, also a very important sensor like an IMU that have to control the position of a particular part, for example the arm, of the complete position of the rover. Another example is the control of an actuator. We have a lot of actuator on the rover, for example the BLDC motor for the mobility, the stepper motor for the arm and the steering, etc. etc. Other example are the interface, the firmware needed to interface a board with another submodule, for example the radio module, and the most important things is the communication between two or more board, for example with via Ethernet bus, and we use this protocol called MQTT, CAN bus, SPI, etc. etc. Also UART protocol, etc. Okay, for the firmware development we use a lot. We use principally the ST microelectronics parts, because they are very powerful. For example, the ARM Cortex M4 and M7 are very very powerful microcontroller. The M4 is used, for example, in the lowest level, for example, to control a motor or to control read sensor, etc. And the M7, that is a very powerful microcontroller, is used in a higher level, for example, to execute the mobility controller, the inverse kinematics for the arm, etc. This microcontroller were chosen because it has an Ethernet interface, a built-in Ethernet interface, that is very useful for our purpose. As we use all ST microcontroller, also for development, we use STM32 CubeMX for initialization of the code, and some other tool from ST. Okay, so this is a slide that represents the most important things, I think. So the cable management and the internal communication. The cable management is done with a software called cabling that is wrote in Turing. Is a Turing company that created this tool. Is our sponsor. Is a very powerful tool because allow us to define and wrote all the connection of a cable, to define the connector pins, etc. etc. So below you can see a very big connectors that I think, but I'm not sure, we will use this year to connect, for example, all the left or right part of the mobility to the wall system. So for our work group, we are looking for people that that are interested in the other hardware development, especially in the analog development and the simulation of the analog circuit developed, and also in the PCB development. But we need also some people to work in the firmware. Is better if you know the STM32 microcontrollers X system, but it's not very necessary. In the end, it's important that you have you like to work with your hands, to touch the circuit we have developed. We have to solder this circuit. So test this circuit. So it's also important to work with hand. So thanks. Now it's time for the computer scientist, and they will be Francesco Vecchia and Federico Cucinella.
So, hello everybody, I'm Francesco Vecchia. This year I'm the leader of computer science. My story in the team begins 2 years ago. While working in Politecnico, I saw a group of people playing with a rover in the courtyard. So I decided to go to Recruitment, and they made the mistake to accept me in the team, so here I am.
I'm Federico, and I've been in the team for 3 years already, probably. I don't remember actually. And I just I knew one of the members and just walk around in the lab for some time and end up doing that entered the team in the middle of the year and take part of it because. We end up to get well with each other. So here I am, and I worked with the front end of the GUI for the control of the rover, and I helped with building a stronger intercommunication system with MQTT, making a little standard to make the whole the parts of the rover with electronics and computer science to work well together.
So, what we do as a computer scientist in the team? We do exactly what you would expect a programmer to do. So we try to make a software. We fail miserably, and we iterate until the rover magically starts to work. Our role is to make the rover as autonomous as we can by rising layer by layer the abstraction levels of our system. An example would be from low layer of abstraction to high level of abstraction is, for example, the rover. For example, hey rover, move the front wheel at 1 RPM. One level up could be, hey rover, move in a certain direction. So the software should now coordinate all the wheels together. Another layer of abstraction can be, hey rover, follow the waypoints in space. So now the software should tell the rover the direction to follow. Also taking in consideration the limitation, the mechanical limitation of the rover, for example, steering angles and mechanical stresses. And we can go on. For example, the rover should be able to go from point A to point B, avoiding dangerous terrain, for example rocks or dangerous terrain. The last level of abstraction can be something like, hey rover, win the competition. And when we will reach this level, I think the computer scientist's job is done in the team. Okay.
So these are the technologies we use inside the computer science department, and more or less they are common to almost all the subsystems inside the rover. And you can probably have done something already with C or C++. We use CMake to automate the building process and possibly in the future maybe also the deployment. Then we use Git with GitHub for the code versioning and management. This is something that is in the latest years in Politecnico has been seen by the students of computer science. Maybe you already know it by yourself. With us you will try to work with it in an actual environment, maybe a bit more real than with the exercises that are done in Politecnico and such. We mostly develop everything on Linux because the main board of the rover runs on Linux, because it's a spatial board that is made up with that. And we use also CUDA for the vision system and computing this kind of stuff. And as for the GUI, we choose to use web technology, so the front-end application, as we will see, is a web application for all of kind of reasons. And also we use MATLAB. It has been used for making for example, the mobility system, to the mobility controller, that is a rather complex system that we run on an STM board, as you've seen, but the code is written using MATLAB and Simulink. And you can see a little breakup of, a little scheme of the main board and what it does. So on the main board, that is an NVIDIA Jetson, we are going to use the Xavier model for this year, it seems. It will run the autonomous system for controlling all the autonomous parts of the rover. Then also the vision system that using the little camera that you see there, that is a Z camera, that is a stereo camera that can map the terrain and locate with odometry the rover on the field, and all the computation is done by the NVIDIA Jetson itself. And everything, as I mentioned earlier, is communicating through MQTT. And the broker is runs inside the Jetson board. And to MQTT, all the boards, the STM boards and other kind of board that can external to the main one, are communicating through Ethernet with MQTT. And on the same connection, also the web application that controls the rover can directly talk to each of the subsystem, even if it's not on the main board. It will clearly pass by the main board through MQTT, but it will be dispatched even without direct control from the actual main board. And for this year, we are probably going to make a special part for controlling for the vision system using VR, to see if we can have a better vision of the fields and try to be more immersed in what the rover sees outside. And because sometimes the cameras seen on a screen are not enough.
Okay.
I would like to add that the VR technology we want to use this year is directly connected to the mapping software. So, for example, the behind idea is something like the rover is going to do tasks on a panel. So in VR we see in third person the rover and the panel, and we are able by VR controllers to virtually move the rover arm to the object we want to interact with, and so we are more aware of what the rover is doing and where is the rover. So this is our goal for this year. Okay, our work covers various fields of computer science. For example, we need to develop microcontroller firmwares. So if you choose to be a low-level developer, you will work closely with electronics members. We need to define communication standards between boards and high-level software. We need also to develop modules like, for example, a module that can make the rover navigate autonomously, or make the arm move autonomously. And going higher in abstraction, we have also a module called autonomous system main, that which purpose is to coordinate all autonomous system in a mission. So we describe to the autonomous system main module the mission, and the purpose is to activate and deactivate all the modules in a coordinate manner. So this year we're also looking for web developers, and we need to develop modules in our web app to control the rover. And another field that is covered is integration, documentation, and software design, as our software can be very complex, and so we need people to work on this.
And this is a little slide on how the GUI, so the graphical user interface of our rover is a modular environment in which each subsystem can have one or more modules associated to it, and can talk directly through MQTT over WebSocket to its module. And the first time that the web app was developed, it had a backend on the rover running. Instead, this time, as you can read from the name, it is standalone. That means it doesn't need a server to be connected to, because we can say that the server itself, the server is the rover itself, because the actual server is the MQTT broker, and it connects to the broker, and it dispatches all the commands through the correct subsystem, thanks to how MQTT is built. And it is modular. That means that each subsystem can have its own module that can't go against other modules, can be activated or deactivated, and the errors can be insulated and debugged without too much effort. It is used using Vue.js and Quasar, that are like rather bleeding edge technologies for web development, and it seems to be quite reliable for our purposes. And this is more or less.
So the skills we are looking for in this year recruitment are basically the following. So we are looking for experienced people with Linux. Another skill very important is C++, because the majority of rover systems are written in C++. Object-oriented programming is another important skill, because in a big project like a rover system, the object-oriented programming is mandatory. So if you know how to program in object-oriented programming, good. So we are also looking for web developers to make the web app to control the rover, and it's important to be able to develop a software as a team. So you need to be open to other ideas and to develop a software according to the standards that are defined in the team. We also use Git. In particular, we use GitHub. So if you know Git, it's a good thing. Also, if somebody have experience with computer vision, I think it's an important point. And another skill we are looking for is handling big projects without freaking out. I mean, for example, the ability to break down a big problem in little ones. So choose the right way to structure the code using object-oriented programming to simplify developing and maintenance of the software. I can show you the main board of the rover. So this here, this was the main board of the rover. Is a Jetson TX2 model. This year the main board will be upgraded to a Xavier, like Cucci said. And basically that's it for computer science.
Yes, the only thing I wanted to add is for the web development, since it seems that Vue is not really well known, as one of the courses of Polytechnico from web application uses the React framework for the web application course, but if you already know React or maybe Angular, then Vue is not that difficult to learn above it, but also to start from scratch is not a problem. As I made the last years, I think also the coming year I will make a little course, if we want to call it like that, to see how Vue works in our environment. And anyway, the modules that have to be built are in a way easier than a full web application to be designed, since the framework, the web application and the workspace around it is already made, and are just the modules that need to be built.
Okay, so we pass the seat to scientific department. So
Hi, I'm Alessio Zaino. I am here to present you the scientific task. The scientific task is a subsystem. The scientific is a subsystem of the rover built to perform the scientific task. It's divided in the scientific analysis that I do myself and the deep sampling system that is done by Sarah. The scientific subsystem is very ambitious. We are looking to find life in soil samples. Those samples are meant to be collected on the soil, and after dye staining procedures, it will be classified as a soil with life, without life, or with dead life. This system has already won some, even if in theory has won some awards in the IRDC, that is an award challenge made by the Mars Society Asia. The Team Diana has won the Innovation Award with our system. The requirements for life detection are that we have to collect a sample of soil, do any measurement on it on the rover, and classificate as alive or dead. Also, we have to collect a rock sample, do measurement on it, but without altering them. So no chemicals on it, no breaking it, etc. Another big this method is known as a biology method, but doesn't exist any system that can do it autonomously. So we have to build from scratch. What we have now, this is a CAD that illustrates what we want to build. On the left, the white boxes are boxes that divide the soil in two containers. A container has sensors, normal sensors like temperature, humidity, pH, etc. The other half does the dye staining method that consists in watering the soil, making the water drop on a microscope slide, and going under two chemicals that will show under a microscope if the bacteria on it is dead or alive. What we need? I explained to you the method, but the method to find life on rocks here is a bit shaky. We tried to find a way, and the better way we found so far is to have a cotton stick, water it, touch the rock, and do the analysis. That's very shaky as a method. A better method would be better. And all microscope, we would like to have a fluorescent microscope, but they cost a lot. So we have to make a custom-made one. And we don't have an idea so far. So it has to be built from zero. Sensors are generic sensors. The GAM, the glass unit management, is way to move the microscope slides that for now we have a carousel, but it's still open as an idea.
Hi everyone, my name is Sara. I'm a civil engineer and geotechnical engineering student. With my colleague Alessandro, that is a mechanical engineering student, we worked together on a deep sampling system. And that's the most important part of our work. We did it together. So we shared our knowledge, and that's how we reached a solution. Everything started from the ERC competition that asked us to do some tasks for the scientific part. Requirements were drill different levels of soil cohesion and hardness. That, for example, can go to silt from rock mass, so they are very different and must give a lot of tension. Then we have to catch a geological deep sample that is below the surface on 15-30 centimeters. Then we have to collect several measurements of the sample, such as weight, volume, and other parameters like humidity. We have to deliver samples in sealed containers and then present a scientific report. So what we have now, we designed a prototype of a double coral barrel sample. We started from biology, we read a lot of books, a lot of research, and then we created this prototype because we needed something new. What we do in reality here on the Earth is with bigger instruments and on different situation of soil. Here we have to work on a soil that is very uncohesive, like sands. And so it's really hard to keep the sample. Now that's what we create. So what we need now, we need to improve the catching system. Our prototype of catchers have still some steps that can be better, because as I said, it's really hard to keep that kind of soil inside the sample. Then we still have to do the measurement on the continuous sample taken, because it is a core. We can't touch the sample because otherwise we would modify the stratigraphy, so we have to do measures on the core. And then we have to improve system autonomy, while we still need a human to take the sample from the core. We still need to make the system autonomous. So all the scientific department is looking for people. We need people willing to create a new system from the beginning, to start a new part on so how we can make it better, this work. Then we need people willing to take a more theoretical and research-based approach to the system development. We also need people with knowledge about chemical, biology, soil and environmental properties. So we are asking you about your knowledge. And then people with knowledge about optics and lasers. That's it. Thank you for your attention. Now we leave the place to another Alessandro that will speak about media.
Hi, I'm Alessandro, and I'm talking about the media and design division of our team. That is an aspect we unfortunately neglected in the past years, although it being a very important field of our activities that really needs and empower what we do. Fortunately, that's not our current level. We are a bit better than that, but for up to now we never really had a division of people tasked with specifically taking care of the aspect of the team image, and that's what we are trying to do this year, is to organize and give more structure to this field by funding a new division, that is the media and design division. why we need that? And we need that because we have a big presence on the social and on the outside world. We have many public relationships, especially with our partners and our university. We have many social accounts and even a website that needs to be maintained. We have a specific strategy. Then, then we also need to develop all the graphics and videos that can help in the management of our image. But also we have some important tasks for all the competitions we participate that requires us to develop a video demonstration of our rover. So video making is further more important for our activities. And then we also need some people with a different background from the technical one we normally have, that can help us in the design of subsystems and the user interface. What you can see here is like a design made by one of our previous students who was a design engineer for the user interface of our control system, the web app. So what we are looking for now, we need people willing to work in this field. So with graphic design, video making, or even as web editor, and someone who is willing to manage our social media. That's our important aspect, as I said, and very different from the usual background of an engineering team, but so important. And of course, any kind of experience with any of the tools needed in this environment is appreciated. But I want to assure you that if you don't have any of these skills or knowledge, even in this field or in the previous one we talked about during the presentation, you shouldn't worry too much, because background knowledge is just one of the things we look for in our team member. In particular, we really care about the personal behavior and soft skills of the people. And about that, now I leave the stage to our Francesco, team leader, who is going to explain better like the profile, the personal profile of who we are looking for. Hi again. So again, we are looking for new members, and we like to play. You probably have already understood that we play with what we do. We play engineering, we create robots, we experiment some different things, and the most important thing for us is how we say with our colleagues, our mates in the team. We look for dynamic, resourceful, and passionate team player. We want people like us, basically, and people that want to deal with challenges and play with us to build rovers. And if you have this kind of passion, this is the right place for you. And I hope we will meet in the team after the recruitment phase. For the knowledge, it's secondary usually to us, and usually it's not so important if you are intrepid, resourceful, and you manage difficulties, especially if you love team working. Basically, it's like playing a sport with other players. You have a team, and you want to achieve a good match or probably win the game. We don't know, but this is basically like a sport but with engineering. So if you are passionate about this, you probably will like to stay with us. We offer several things inside the student team, like the other student teams after all. There are some opportunities inside the academic area. For example, you can write thesis inside the team, for example experimental thesis, and we already had several theses inside the rover. And you can also substitute some free credits. You better ask to the secretaryship inside the Politecnico, and put some in practice some aspects that probably you will learn inside the lessons. And this could actually be a very good opportunity to get some skills, soft skills that eventually will be evaluated in the future for a position in the world of work. And you could put some in the curriculum some kind of what you have learned inside a student team. Basically, you could manage to work inside a team. You could manage to play together with other persons. Usually, it's not so. Usually, engineers works together, never alone. So, learning to work together is very, very important. This is the most important thing you will learn inside a student team, and it will give you also satisfaction inside a team because you will try, you put efforts to make something work, and after it works, it's very, very it's a very good achievement for everybody. Now, this is probably the moment you have waited. This is the question times. We have collected some questions you have written inside in the chat, and now I will call each member if there is some aspects that is specific or particular for a kind of area of the team. I will put the face mask, so sorry if you will listen differently now. So, Lucrezia Lavaglio, where mechatronics can fit. This is a question that we have every year. Mechatronics can do a lot of jobs, but mostly for automatic control and stuff like that. They are very quite demanding, probably, but usually it's very important for a thesis or other aspects for that. For example, all the wheels of the rover are controlled singularly, and there is also a steering system. This kind of aspect for mechanic, electronics, you have to control this system. With the knowledge you can get from your course, your study plan, you could develop a model to drive the rover. This is an aspect we have improved during these last years. Or for example, the kinematics of the arm is another aspect, or there are many other in mechatronics things inside a robotic system. You could imagine there is also a gimbal that needs to be integrated with the arm, so there is a lot of things that need to work. If I don't answer your questions, you could rewrite them and we will try to answer again. Thank you for the question. Giuseppe Falcone, as a first year student, what will be the main skills that I should have in order to be chosen? I have answered this in the last slide. we hope that all members are play with us. Is a team, and this is the first characteristic we see. We look forward, and it's secondary, the knowledge. If you are capable to learn things on your own or with other person, and you want to you can learn new things, it's perfect. This is the thing we look for. Usually we don't know everything inside the Politecnico, and usually we study. Maybe we get some little knowledge that usually you cannot get on inside the lesson, and this is also what putting in practice is of. You start from a theoretical knowledge, you could get some practical knowledge, and combine the two aspects of engineering. This is what is made a student team also. And we also take some students from the first years. It depends from person to person. Thank you for the question. Daviano Carra, can the students from the first year join you? Yes, it happens, and usually they get also stay in the team all the year of the study plan, and they get the knowledge they want. There is grow possibilities inside the team. I don't know to pronounce your name, sorry if I mispronounce it. Hamza Ahmad, student from the first master level can join the team, yes, as said before. Lorenzo Caraccio, lo scorso anno non c'era la necessità di studenti di ingegneria meccanica quest'anno. Yes, I know what you are meaning. We also take this year mechanical engineering students. So we basically open this recruitment season the doors to every student inside the Politecnico. Gabriel Romero, I think I missed one part regarding electronics. What is the software that you use for the analog simulation of circuits? I will call the leader of electronics to answer to this question. So, Eduardo again.
Hi. For the simulation, we mainly use a SPICE simulator like LT Spice or PSpice. I wish it was an answer for you.
Leonardo Palmucci, conoscere già da ora i tool elencati prima della selezione hardware development è strettamente necessario?
No, it's not necessary. It's more important to know the base of the electronics, especially for the digital electronics, for the programming part. And no, you will study it if you will enter in the team. No, it's not necessary.
Thank you for the question. Now there is an answer, a question for computer science. I call Francesco, you already met before. Maybe I mispronounced the name, sorry. Ashale Johnny. Da quest'anno al primo anno non ne insegnano più C++, ma Python. È uno svantaggio oppure le cose insegnate al primo anno sono così poco utili che non fa differenza?
So
Thank you for the question.
I translate the question in English for English people. This year at Politecnico they will not teach C++ but Python, and the question is a problem. So no, it's not a problem. I just had a strange reaction because in the team is there are some debates on this, but it's really not a problem. The thing you have to know is are the basics of how to develop a software. It's a preferable skill to know object-oriented programming, and Python is an object-oriented programming language. In the team we use C++, not Python. So if you're interested to join the team, it's necessary that you are ready to learn a new programming language. So if you're willing to learn C++, it's not a problem if it's not an teacher in Polytechnic. Okay.
We don't know if it's for randomly or because of needs, but actually we use the same kind of programming languages of aerospace industries like SpaceX, and they use C++ for embedded systems and all the computers, and for the base stations, the control station or the mission control, they use JavaScript, and they are very similar. This is usually we choose the programming languages based on needs. Yeah. Python could be used on data science, but depends on the cases. Thank you for the question.
Thank you.
Another name difficult for me, Kind Ilmes, I don't know the pronunciation, sorry. How do we apply? This was the last question. I will, in any case, answer. I ask if there are other questions written in these few moments. Yes, please bring me the questions. How to apply? We have a Google form for you. You can with the face mask. We have a Google form. You have to complete in order to participate to the team. We will evaluate this Google form and eventually call you on the email you have written in this Google form, and organize a call with us eventually on Skype if you are away from here, or we will let you know how to meet, and in this interview we will exchange some words, and after these two phases, actually the Google form and the interview, we will let you know if you are a member of the team Diana. So the Google form will be available from tomorrow morning on the website on our website, teamdiana.it. You can there is in the description the link to our website. There is a section, it's called 2020 Recruitment. There you will get the Google form and the instruction you need to know to apply to Team Diana. Then you have time up to Sunday evening on 12 p.m. In the evening of Sunday, and then you will get, after this week, at the end of the week, you will get the answer on for email. In any case, if you are accepted to the interview or not. I hope that this is all. Yes, and so check our website tomorrow morning. The other questions are: what language do you guys tend to use? Italian or English? Both of them. We usually, if there is, we have a rule. If there is English person inside the team, we speak English for to speak internationally inside the team. We also have in the past some students that were foreigner, not Italian, and we speak English in any case. We also participate to competitions that are in foreign countries, so English is quite important for us. But also we speak Italian if there are Italian guys inside the team. This is we speak both languages. Then again, I'm searching. Okay. How many? Wait a minute. How many hours per week do you meet? It depends on the needs. It cannot be predicted. We can have moments that we need to meet more frequently or not. It depends from the needs, and it depends from how much time you can dedicate to the team. Usually it's not the time, it's the effort you put in the team that is more important. And we can speak in the interview eventually about time management and how you can manage your time. Usually it depends, really. It's not, there are students that stay a few hours a week and others that stay also in the evening working on the project, and they like to work on the project. We also in some period we also haven't slept for in the evening just to complete the project in time. It depends, really. It's not something mandatory. Then thank you for the two questions. How is the recruitment process structured? What does it consist of, and how long will it take? Depends. From the area of interest you want to join, and the Google form will adapt to your questions. And if you want to join to mechanical department or electronics, computer science, medium design or others, you will get specific questions. They are all optionals, and you can complete as many as you can, and try to answer the question you want to answer, or you can. And it's a test, yes, and we will evaluate it for to be accepted to the interview phase. It will take, I don't know how much, it depends on the area of interest. What can an aerospace engineering student actually do in the team? I just accomplished my bachelor degree. I called Leonardo to answer this question.
Hello again. So I'm an aerospace engineer, so probably if you join the team you will be made the same thing as mechanic engineer do. So mechanical projection, mechanical design, and mostly FEM analysis, and then you will build the rover with your hand when it's the time to build. And there's not so many differences in the team between the areas that apply to the mechanic department, and what you will do in the team is equally made from what we need to do and what you want to do in the team, what is most interesting for you, and maybe for a thesis in your course. So you made all the things that all mechanics do, so projection, analysis, and that's all.
Next question. Thank you for the last question. What about collaboration with companies or other teams? With companies we have several sponsors, and you can see them here, some of them. and we collaborate with several companies from aerospace industries to industries for electronics, different devices, and also mechanical industries. There are several of them, and some are very specific. We collaborate with them. They sponsor us in different ways, and they also we can also ask them maybe for an opinion about the project. For the teams, we also participate together. Sometimes we interface between us, and they start some events in the last year, also for the COVID situation. But we foresee that we will eventually participate more together in the future with other student teams. For example, one team is Team Sharp, that is going to be very strict with us. It's a management team mostly, and also for other student teams. So this is for the future. There will be opportunities for both companies and student teams. And then, if I study computer science abroad, is that a problem? I call Francesco.
Hello. So it's not a problem, but I think a great part of being part of a team is that you make some great friends, and working from home. I think team building, it's not the same than meeting in person. So if you don't have the possibility to come in Politecnico to work, it's absolutely not a problem, as we are computer scientists, so it's not a problem. But if you can, it's advised.
Usually it's for humans like to work together usually, hopefully, and it's very funnier staying in the team and work together. You can work just for the work you have to do, but usually collaboration, teamwork, staying together is the best part of the team. It's something I advise to tend for. In the last year, we upgraded our remote work capabilities for the virus situation, and we tested several systems to work together also from the distance. So we know it's not a problem. It's just for the human aspects to work to look for. Thank you for the question. Will the recruitment form will be sent after this live? As I said before, tomorrow morning on our website. There is a section dedicated to this. Then I read that take part of the team can be substitution for free credits of the laurea triennale. Is it true? And is true how many hours you have to do in the team to obtain 6 or 12 free credits? Okay, yes, you can obtain some credits participating to a student team and exchange them a free course. But for every CFU, every credit you get, you have to stay for the Politecnico 25 hours per credit. So if you multiply it, you get how many hours. Then the department of your study plan will evaluate the work, as also our professor will evaluate the work, and also they will ask us if the work is correct. And after this process, they will be after the evaluation from the professors will be assigned the credits. And I have to say that usually participating to a team is more time demanding than it should be. I suggest you to do a course instead of a student team. Student team is best for who is passionate to work with a team and to practical devices. So I suggest you to not enter in a team if you just enter for the credits. Usually it's a bonus, not a goal, because there are easier way to obtain credits. Then, thank you for the question. Python is not poisonous, but could still kill you easily. Be careful, even if even in Politecnico. We don't have this kind of strict mentality, but Python usually is not good for our purposes, but we can also use it. We're just kidding here. Potete fare un riassunto in italiano, per favore? Ok, forse alla fine possiamo dedicare qualche minuto. For the mechanics group, will be there a crash course of some sort for the software that you guys use? Yes. Leonardo will answer this question.
Hi once again. Yes, probably there will be a crash course on the software we use. Basically, there will be a crash course on SolidWorks for people who don't know SolidWorks, but because it's the basis of the mechanical work. And then probably will be some courses on Patron and Naturam for analysis, or MSc Apex, that is a little bit easier to learn. But yes, of course, when someone is in need to learn a new software and there's someone in the team that already knows, it's like a passage of knowledge between the team members, the old team members to the new team members. So yes, there will be some courses on the program. So thanks for the question.
Then, unendosi al sottogruppo di Computer Science è possibile collaborare al team restando a casa? È stato già risposto prima, forse è meglio ripeterlo in italiano. Sì, è possibile, ma si perde parte dell'aspetto umano di lavorare insieme. Si può fare, abbiamo già testato, dato il Covid, nuove piattaforme, si può fare, dipende dalla persona e da come vive il team. Si può fare a livello pratico, magari a livello umano è poco soddisfacente. Then, for website you mean on Facebook? Yes, also it will be available also on social media, both Facebook, Instagram, but we also need a website on the World Wide Web, we used to be in the past. It will be available on all our platforms. Then, un ingegnere matematico può essere utile nel team? Yes, a mathematical engineer, yes, it could be very useful. There are several aspects that we need to consider also from a mathematical aspect. Yes, this is there is for example a Kalman filter my colleague suggests, or other aspect. There is a work also for mathematical engineer. Thank you for the question. La domanda di prima, was a question for asked for a sum up in Italian, so I will start speaking Italian just for a few informations. I will then speak English again. Magari per la parte di reclutamento è la parte più essenziale da conoscere, dato che una presentazione è stata fatta venerdì ed è disponibile su YouTube, sui canali di WeOpen dell'altro team studentesco. Per entrare nel team c'è un Google Form e sarà disponibile da domani mattina e sarà possibile rispondere fino a domenica sera alle 23:59 di sera. E ci saranno delle domande che consigliamo di rispondere, sono facoltative in ogni punto, e comunque saranno valutate per poter accedere alla seconda fase del reclutamento, che sarà un colloquio in presenza o no, non lo sappiamo, ma vi comunicheremo per email se passate alla seconda fase oppure le modalità con cui partecipare. Dopo la seconda fase vi comunicheremo se siete effettivamente entrati a far parte del team, speriamo di sì, o in caso contrario vi comunicheremo in ogni caso l'esito. And yes, maybe there are all the questions. I just want to show you that we also play with mini rovers, and sometimes we just play for fun and or just for testing purposes, and we do crazy stuff also. It's very intriguing as a team. Educational, my colleagues suggest. So there are other questions. We will wait some minutes before, and this is the end of our presentation. Thank you to everyone, and if you have some questions, we wait here a few moments for you, and we hope to see you maybe in the team. There is a person that asked if I'm late. Can you repeat all you said? Thanks. Yes, it is one of our team members that is not here. No, you will be banned from the team. No, it's not for that. We like kidding a lot, and this is part of being in a student team. Sir, as I'm not in Italy, will you conduct interview on Skype? Yes, it could be. Yes, we eventually for needs organize interviews on Skype or similar platforms. There is another question. Are there any possibilities in your team for material engineers? Yes, we conduct studies for space grade materials, and for example, our wheels are made of harmonic steel. This choice was made because rubber cannot go in a space environment. It has several complications due to space environment, and we opted to harmonic steel because it was a better choice. Also, materials for plastic, for examples, or metal alloys, or other kind of composites. Maybe my colleagues want to answer. Okay, it's yes, there is a place also for material engineers, and we had a few of them in the past. Now we have any material engineers, so I suggest you to try to enter in the team. And okay, I think we can end here. Thank you to everyone, and I hope to see you in future, eventually in in the recruitment phase that will begin from tomorrow morning. Bye to all and see ya.